Take a look at where we left off last time. If I click start, you can see we have a game. We can shoot our enemies, and if they're tagged enemy, they disappear. For now, let's go ahead and open up our level, and I'm going to delete all of these enemy tanks. What I'd like to do, let's actually move this into view, and select our main camera and increase the size a little bit so we could see our awesome tank and enemies a little bit better. All right, I'm going to create a movement script for my enemy. So inside this scripts folder, I'm going to create another C# script. All right, so it's just called SI for Space Invaders Enemy Movement. Let's go ahead and open that up. Now let's create some variables that are going to affect the movement of our enemy ship. Now, if you've played Space Invaders before, really they just move in one direction. So essentially, they typically move like horizontally until they hit the edge of the screen, and they move down one, and then they reverse direction. So we're kind of following that classic gameplay. If you want later on your own, if you want to expand on this, you can add a shooting mechanic where periodically they'll shoot. But we're kind of going slowly by writing each game at a time. So I'm going to go ahead and pause the video. I'm going to write out all of those variables. So this first variable here, speed, is pretty self-explanatory. It's the speed in which our enemies are going to move. Then we have downward step. So as I mentioned, our aliens are going to move in one direction, then they're going to step down, move the other direction. And then we're going to have a private, just a variable, a boolean that's just checking. If we're moving left, then we want to do something. If this is set to false, that means we're going to move to the right. And then this is a vector 3, which is our x, y, and z. This is just going to save the initial start position. So how do we do that? So I'm going to grab this, paste it in start, and then I'm just going to say equals transform dot position. So this is how we're storing the current position of our character, or enemy player rather. Now we're starting our moving left to true, so we're going to start off our alien moving in the left direction. I'm just going to go ahead and use update to move our character left and right, and then to set the position and have it shift down. So I'm going to go ahead and type out those if statements now. All right, so we have the update method here, which we know runs every frame. And if moving left is the same as true, which we said here, we're going to translate the character's position left times speed. And remember, we use time.delta time to sort of normalize the speed. So let's save this and return to Unity and hook this up and see what it does to our enemy. All right, here we are. I really kind of don't like how squashed this enemy tank is. Let's see if we can get in here and adjust that. Now with our enemy tech selected, let's kind of shrink some of these down a little bit. Let's just grab our SI enemy movement script and drop it on here. And we have a public variable here for speed and downward step. So I'm going to go ahead and press play, and you can see our enemy is moving. Now we could just sort of set it up where when we click our welcome panel button, or we have to wait till our, well here, let's turn this off for a second. So let's press play, and I click start, and now you can see it's moving. So he might be moving a little bit too quickly, and what we can do is at first just set this to something like 1, and then over time we'll have our game manager update the speed of our enemies, so as they get closer or the more you kill, the faster these characters get. So it adds a little bit of a game mechanic there. So let's go ahead and script it. Let's script the opposite movement. Let's jump back in to our script editor and continue to work on the enemy movement. All right, so I'm just going to write this out instead of pausing it just so you can see it. So if our character is moving left, we want to move our character essentially to the left. Now, if you recall, the else statement is just the adverse of this, or the inverse of this. So if we're not moving left, then we're moving right. And then what we want to do is move our character vector3.right. Now, if you recall, this is being controlled by our variable here. So let's go ahead and make this public so we can play with this back in the viewer so you can see how this works. So Um, let's jump back into Unity. All right, so here we are back in Unity. And if you remember, we have this variable here, and I'm going to untick it. Now you can see it's moving right. So remember, a Boolean variable is just true and false. So if it's ticked on, that means our character is moving left, and it's kind of moving really slow, which might be fine because we might have like a bunch of these. And so that's kind of cool. All right, so let's go ahead and finish up the script so our character actually steps down when it hits the side of the screen. Actually, before we do that, um, let's make sure we know we'll probably make these public variables so we can adjust it later. But you can see that this is our character at 0. And if I move my character to the left here, you can see that it hits about -9. Let's see, -10 here. It gets to about -10, and so that means +10 would be the other side of the screen. So we have to, if we have a grouping of these, maybe we have them go down one at a time as they hit -10 and 10 for the X position. Remember, we're working with the X position here. So let's jump back into our editor and script this. All right, so um, we can add another if statement here, and we can copy. Let's see. Let me go ahead and pause this because this is going to be not too difficult to code, but it might be a lot to type out and hear all the clicking. All right, so let's take a look at this in action. If our current position on the x-axis is less than -10, remember that's when our character is all the way to the left, or remember these two bars which are located above the enter key, transform position x is greater than 10. Let me save that. We're going to do something. And what we're going to do is we're going to set the current position of our model. We're not going to shift the x position, right? Because a vector 3 has 3 parameters. We're going to shift the y position minus downward step, which if you remember we set to 1. So we're just going to set the position of our character down by 1. And we're not going to do anything with the z-axis. We're going to leave the z-axis alone. So let's jump back into Unity and see how that works. So here's our character. Let me go ahead and turn off world. You know what? We'll just play through it every time. It's not too slow. And actually, the enemy, I'm gonna kind of double up the speed on the enemy. That is moving too slow for me. All right, so I'm gonna press play, and I'm gonna start my game. And here's our enemy moving, and boom, shifted straight down. Now the problem with this is you noticed it just keeps moving down by 1, right? Like it just shoots straight down. We want it to move down 1 and then shift all the way to the right. So let's go ahead and fix that in the code. Change up a couple things. Let's make it a little bit easier to set these boundaries. So I'm going to add 2 more variables up here, and we'll just set them below here. They're going to just set the left and right boundaries. All right, so we have 2 new variables here. This is for left boundary. So I'm just going to set this instead of 10f. And then I'm going to grab my right boundary. And notice they're just set -10 and 10 again. But this will give us a little bit more control when we go to code our game. And then the last thing we're going to do is essentially in this if statement is if we hit these, we just want to change the direction, our moving left direction, to be equal to not essentially whatever moving left is. So this is kind of the same thing as saying this is moving left is now equal to the opposite. So if it's currently set to true, we're going to set it to false. And what's nice about that is it's like a nice clean way of always switching it as we hit both sides of the screen. So let's save this and let's test this now. All right, here we go. Let's press play, start the game. Character moves to the left, moves down by 1, kind of a little poppy, just like in the real game. Boom, very nice. And we can still destroy our enemy. Let's see what happens when we add a few enemies in there. We also want to make sure that we are really spacing these out. Because you could have a collision issue. All right, so let's start our game. Ooh. Oh, it looks like I. Hold on a second. What am I doing here? All right, let's give that another shot. All right, I'm going to press play, start the game. I made them a little bit shorter because they were kind of clipping into each other. Like you can see how they're doing that there. So what I would do is play with, like just grab really any of these enemy tanks and maybe change the door down step to maybe 1.5 so they go down a little bit more. To start here. Boom. We got one shot. 1.5. Yeah, they seem to clear a little bit better. You can also just adjust one enemy tank, make it like 1.7. And because I made these prefabs, which remember you just drag them into your prefabs folder, you can just do overrides apply all. And now when I click on each one of these, oh, actually, you know what? I forgot that, which is a really nice feature, Unity. Each one of these are treated independently. So start here, boom. A little bit more clearance there. All right, and the next level, we'll take a look at how we can do something called object pooling, which is going to save us some memory because as we delete this, we're just going to add them back to a pool. But for now, that's our enemy movement.